Context-free grammar shows us how to generate a syntactically valid string of terminals. Begin with the start symbol. Choose a production with the start symbol on the left-hand side. Replace the start symbol with the right-hand side of that production. Now choose a non-terminal A in the resulting string. Choose a production P with A on its left-hand side, and replace A with the right-hand side of P. Repeat this process until no non-terminals remain. As an example, we can use this grammar for expressions to generate the string slope times x plus intercept. The start symbol is expr, and we can expand it to expr op expr. The expr at the end of the expression can be replaced with id, and the op can be replaced with the addition symbol. The remaining expr in the expression can be expanded recursively to expr op expr, and the process repeats. We replace expr with id, replace op with the multiplication symbol, and replace expr with id. Replacing each id with the corresponding identifier completes the process. The arrow metasymbol is often pronounced derives. It indicates that the right-hand side was obtained by using a production to replace some non-terminal in the left-hand side. A series of replacement operations that shows how to derive a string of terminals from the start symbol is called a derivation. Each string of symbols along the way is called a sentential form. The final sentential form, consisting of only terminals, is called the yield of the derivation. We saw in Chapter 1 that we can represent a derivation graphically as a parse tree. The root of the parse tree is the start symbol of the grammar. The leaves of the tree are its yield. Each internal node, together with its children, represents the use of a production. Here is a parse tree for our previous example. The tree is not unique. At the second level of the tree, we could have chosen to turn the operator into a star instead of a plus, and to further expand the expression on the right rather than the one on the left, which would have given us a parse tree that looks like this. A grammar that allows the construction of more than one parse tree for some string of terminals is said to be ambiguous. Ambiguity turns out to be a problem when trying to build a parser. It requires some extra mechanism to make a choice between equally acceptable alternatives. In this class, we will avoid the use of ambiguous grammars. We will also avoid the use of so-called useless symbols, non-terminals that cannot generate any string of terminals, or terminals that cannot appear in the yield of any derivation.